In this video, we'll see how to perform an approximate F test or pseudo F test when we cannot have an exact F test or exact test statistic. And this is particularly happen for mixed models when you have both random and fixed factor. The typical scenario would be nested, split plot, repeated measure, subsampling, etc. So here is an example for one partly nested design. In this case, if we analyze that this design, there is these factors, so institution, if it's a random factor, and then these are fixed, this guy fixed, and then also instructor is nested within the in the institution. So if we analyze this data, we already did that. Let me show you again how to do that. Simply basically click on stat and ANOVA. I just did it, so my Minitab has it here already. So generalized linear model. So basically response is the performance. You can read that problem going back to the video, and then random nested here. B is nested in A, instructor B is nested in institution A, and also A is a random factor. So if you select random here, then this B kind of get default random because it is nested within the institution. Now then model, select everything, hit OK, hit OK. So you get this result. So I have copied that already in the PowerPoint. Let me show you that. So here is the result. Now here it says that for this particular situation, it cannot produce an exact F statistics. So exact F value does not exist for these. So how do you do that? An example we have shown in the earlier module in the expected mean square. So in this, for example, the factor C is random. Then this term C does not have any exact F statistics. What that means is, if you can see this part, the component for the expected mean square, that this is the C component, and then the error associated with that is this piece, and there is no other term that associated this error directly. So then what do we do? In this case, what we can do is basically, if we add this guy, you just have to kind of do it, kind of looking at it. So if you add this two minus this, so this plus this minus this will produce basically this piece. So as you can see here, so and then in that case, the degrees of freedom, then the way you determine the degrees of freedom for the numerator. So this is the divisor for the F statistics. For the numerator, that is still the, for F test, that's the MS of C. So the degrees of freedom for that would be basically C minus 1 divided by the DF2, or this piece entirely, this piece. So let me write that down here. MSSC plus MSBC minus MSABC. So for that F statistics, we need 2 degrees of freedom. Degrees of freedom 1, numerator degrees of freedom, and numerator degrees of denominator degrees of freedom. So denominator degrees of freedom comes from these equations. So let me show you a calculation on that. So we have this analysis, all the information here, the mean square, degrees of freedom, and everything. So here is the expected mean square that was produced by Minitab. You can produce by yourself using this method mentioned in the earlier module in the openeducator.com. So as you can see here, for example, this piece B here, B nested in A, that does not have an exact statistics. So what you can do here, basically, you can add this BAD and this one, and then subtract these two from there, and that will produce basically the error associated with B, which is this piece. So I just did that, and then interestingly enough, it got negative expected mean square. So when you get something like that, that is estimated as 0, indicating that it has absolutely no chance of getting significant because the F value is 0. So, if you look at the F statistics, if we start from here, if the value is 0 here, then you get all area under the curve. So the P value would be basically 1. So there will be no chance of significant. However, if you plug all this number here, I just did it just to show you also degrees of freedom, where you get a fractional number, you always round it up. So in this case, if you want to find it, the P value using MS Excel, you can write basically F dist, then the F value, which is 0 in this case, comma degrees of freedom 1, which is 1. Let me go back and double check the degrees of freedom for BAD. No, that's 2. Sorry, that's 2. So numerator degrees of freedom is 2, and then denominator is basically 0.01, so it's 1, and this will produce value 1. So P value is 1. Now, in this case, it's a kind of extreme, one extreme, but if you have some value here, some degrees of freedom here, then you can find this P value and explain the results. So I hope this explained how to do the pseudo F test or approximate F test. You'll find these formulas and all these expected mean square and all this stuff that I have talked about here in the openeducator.com as a written text as well as this video.